The dark. For almost all of human history, darkness was not peaceful. It was dangerous in a very real, physical way. When the sun disappeared, vision collapsed into uncertainty, and uncertainty was exactly where predators thrived. Large nocturnal hunters could see, hear, and move in ways humans simply could not. We had no claws, no fangs, no night vision, and no real protection once the light was gone. Survival depended less on strength and more on caution, anticipation, and the ability to feel danger before it was visible. Over thousands of generations, the humans who felt tension when night fell, who stayed close to firelight, who avoided wandering into black forests, who reacted strongly to unseen movement, were more likely to survive long enough to pass on their genes. Gradually, fear of darkness stopped being a learned reaction and became part of our biological wiring. Even today, when you are completely safe inside a locked room, total darkness activates the amygdala, the brain's threat detection center, before conscious reasoning has time to intervene. Your heart rate rises slightly, your hearing becomes more sensitive, and your imagination begins filling the unknown with possible threats. Nothing actually needs to be there. The system was never designed for accuracy. It was designed for survival. And from an evolutionary perspective, being unnecessarily afraid in the dark was always safer than being calm at the wrong moment. Fear of darkness is therefore not childish or irrational. It is an ancient survival program still running in a world that no longer requires it. If this hidden connection between modern emotions and ancient biology fascinates you, you are exactly where you should be, because nearly every instinct you feel has a story like this behind it. Heights and falling. One of the clearest signs that fear is built into the human nervous system appears just days after birth. Newborn babies display what neuroscientists call the Moro reflex. When they suddenly feel unsupported, as if they might fall, their arms spread outward, their muscles tense, and they cry instantly. This happens long before they understand gravity, danger, or even their own environment. The reaction is automatic, universal, and deeply embedded in our biology. In prehistoric landscapes, falling was often fatal. A misstep near a cliff, a slip while climbing, or a loss of balance on uneven terrain could end a life within seconds. There were no hospitals, no rescue teams, and no second chances. Because of this, natural selection strongly favored individuals whose nervous systems reacted to height and instability immediately, without waiting for conscious thought. The faster the reaction, the greater the chance of survival. Adults still carry this ancient circuitry. When you stand near a high ledge and feel your stomach tighten, or your legs become strangely unstable, your brain is not being dramatic. It is running a predictive survival simulation, rapidly imagining the consequences of a fall in order to keep you away from the edge. This is why fear of heights feels so physical and so difficult to override with logic. The system evolved to act before reasoning had time to interfere. From the perspective of evolution, this makes perfect sense. The cost of unnecessary fear is small. The cost of ignoring danger is everything. Loud noises. Long before language or complex tools, a sudden loud sound in the natural world almost always signaled immediate danger. A branch snapping behind you could mean a predator. A crashing sound might indicate a landslide or falling tree. Thunder could announce a violent storm capable of killing exposed humans. In such an environment, the individuals who paused to calmly analyze the noise were often the ones who did not survive. To solve this problem, evolution created an extremely fast neurological shortcut. Sound information can reach the amygdala in roughly 12 milliseconds, far faster than conscious awareness. This means your body can begin a full defensive reaction before you even understand what you heard. You jump, your muscles tense, your heart accelerates, and only afterward does your thinking mind catch up and label the sound as harmless. This startle reflex is one of the oldest defensive systems in the human brain, shared with many other animals. It prioritizes speed over accuracy because, in the wild, Speed was what kept organisms alive. Even today, harmless events such as fireworks, slamming doors, or a balloon popping can trigger the same powerful reaction. Your nervous system is not malfunctioning. It is operating exactly as it was designed, treating every sudden noise as potentially life-threatening until proven otherwise. Understanding this changes the way fear feels. Instead of weakness, it becomes evidence of how efficiently the brain protects you, even in situations where protection is no longer necessary. Trypophobia. Some fears are less obvious than darkness or heights. One of the strangest is trypophobia, the intense discomfort many people feel when looking at clusters of small holes, irregular patterns, or textures that resemble decay. The reaction can include nausea, anxiety, or an almost instinctive urge to look away. At first glance, this seems irrational. After all, holes themselves are harmless. But evolution rarely creates reactions without reason. Many dangerous biological threats, parasitic infections, contagious skin diseases, decaying organic matter, and certain venomous animals share similar visual patterns. Detecting these subtly would have helped early humans avoid contamination long before medicine existed. Because infection could spread silently and kill slowly, the ability to feel immediate disgust towards suspicious textures became a powerful survival advantage. Disgust, unlike fear, pushes you not to fight or flee, but simply to avoid contact. That subtle difference is crucial. It prevents exposure before danger even begins. Modern trypophobia may therefore be a leftover warning system, one that once protected humans from invisible pathogens in environments where a single infection could threaten an entire group. The reaction feels strange today because the original danger is mostly gone, but the biological memory remains. Snakes and spiders. Across cultures, continents, and historical periods, humans consistently show heightened sensitivity to snakes and spiders. Even very young children who have never encountered a dangerous species detect snake-like shapes faster than neutral objects. Neuroscientific research suggests the brain contains specialized visual pathways tuned specifically to these ancient threats. For millions of years, venomous bites represented a major risk to primates. Individuals who noticed a snake quickly had a clear survival advantage over those who did not. Over evolutionary time, natural selection strengthened neural circuits that prioritize thin, curved, ground-level movement, the visual signature of a snake. Similar mechanisms appear to exist for spiders, whose unpredictable motion and venom made them equally dangerous in ancestral environments. This phenomenon is known as prepared fear. The brain is not born afraid of everything equally. It is biased toward threats that repeatedly endangered our ancestors. That is why a harmless snake in a controlled environment can still trigger a powerful surge of adrenaline. Your conscious mind may know the animal is safe, but deeper neural systems respond to evolutionary history, not modern context. Fear, in this sense, is not about the present moment. It is about the past still living inside your nervous system. The uncanny valley. Not all fears come from predators or physical danger. Some come from something far more subtle, the feeling that something is wrong, even when you cannot explain why. This is what psychologists call the uncanny valley, the deep discomfort we feel when something looks almost human, but not completely. A face that is slightly too still, eyes that seem alive but empty, movements that are almost natural, yet strangely delayed. Instead of empathy, we feel unease. Instead of connection, we feel distance. At first glance, this reaction seems modern, linked to robots, dolls, or digital animation, but the roots are much older. Throughout evolutionary history, recognizing subtle signs of illness or death inside another human could mean the difference between survival and infection. Skin tone, eye focus, muscle tension, and movement patterns all carried biological information. A body that moved incorrectly might be sick. A face that looked human but lifeless might be dead. And approaching either could be dangerous. Natural selection therefore favored brains that reacted before conscious analysis, producing immediate discomfort toward anything that signaled possible disease or death. The uncanny valley may be the modern echo of that ancient detection system, a warning that something resembling a human is not safe to trust. Your discomfort is not irrational, it is protective. Isolation. For prehistoric humans, being alone was rarely peaceful. It was usually fatal. Humans evolved as pack animals, completely dependent on cooperation for hunting, protection, warmth, and raising children. A single individual separated from the group faced predators, starvation, and injury without support. In evolutionary terms, isolation drastically reduced the probability of survival. Because of this, natural selection shaped the human brain to treat social disconnection as a serious threat. Loneliness is not just an emotion. It is a biological alarm system designed to push you back toward other people. It activates many of the same neural pathways as physical pain, which is why social rejection can feel genuinely painful inside the body. Even in the modern world, where food, shelter, and safety can exist without a tribe, the ancient circuitry remains active. Long periods of isolation increase stress hormones, disrupt sleep, weaken the immune system, and affect mood. Your biology still assumes that being alone means being in danger. This is why friendships, families, and communities feel so essential. They are not just cultural comforts, they are evolutionary necessities written into your nervous system. And if you find these hidden connections between biology and everyday emotion fascinating, this is exactly the kind of deep human story worth exploring further. Fire. Fire is one of the strangest objects humans fear and depend on at the same time. On one hand, mastering fire transformed our species. It provided warmth in cold climates, protection from predators, light in darkness, and the ability to cook food, dramatically increasing the energy humans could extract from what they ate. Some scientists even believe cooking helped fuel the growth of the human brain itself. But fire was never completely safe. Uncontrolled flames could destroy shelters, forests, and entire groups within minutes. Burn injuries were often fatal long before medicine existed. So while humans evolved attraction toward fire's benefits, they also evolved deep caution toward its destructive power. This created a unique emotional response, simultaneous fascination and fear. You can see it even today in the way people stare at campfires or candles, drawn in by warmth and movement, while still instinctively respecting the danger. Your brain learned that fire is both life-giving and life-ending, and anything with that much power demands attention. None of these fears are random. Each one once protected human survival. Fear was never weakness. It was the reason we are still here. And even today, those ancient alarms still live inside your brain, explaining things simply.